All right, these are the last kind of problems that you need to solve for chapter 4. And these are very similar to the ones we did in the previous video with the acidic solution. There's only one more additional step you're going to do for basic, but it doesn't happen until the very end. So we're going to go ahead and solve this just like we did the last couple of problems. And then the very end, I'll show you that last step that you have to do for a basic solution. In a basic solution, you will not have H+, and notice that we do have H+ now, which is why we need to fix it. All right, so just like yesterday, in order to balance this, you're going to need to figure out what got oxidized and what got reduced. So let's go ahead and put oxidation numbers. This one is a +1 because they're telling us it's +1. That plus that's with it is giving us the charge. For the next one, we need to make the chromium and the oxygen add up to -2 because it's a polyatomic ion, so you make them add up to the charge that the polyatomic ion has. Let's go ahead and assign oxygen as a -2 because that's usually what it is. Times 7 gives us -14. We need to make it add up to -2. So the chromiums are going to have to add up to 12 because 12 minus 14 will give us -2. But we have 2 chromiums, so each one will be 6. All right, let's go to the next one. Go ahead and give oxygen a -2. We'll give each hydrogen a +1. And now let's see how much we have. 5 times 1 is 5 here. We've got a -2 plus another 1. So we'll say 6 for the hydrogen, and -2 is going to give us 4. So right now on the right side of this compound between the carbon and the hydrogen, all of that adds up to 4, which means this carbon needs to add up to -4. And we have 2 of them, so each one is going to be -2. Let's make sure that makes sense. -2 times 4 would give us -4. We have 5 here, -2, and 1, and it looks like that should add up to 0 if we add all that up together. All right, over here we have a chromium. It's giving us the charge as +3. Oxygen we can assume is -2, so this carbon is going to have to be +4 to balance out the oxygens, and then -2 and +1 for water. All right, now let's see if we can find what got reduced and what got oxidized. And again, if you find something that got reduced but you can't find something that got oxidized, it means you did something wrong. In the reaction, you have to have both reduction and oxidation at the same time. So I'm going to guess chromium and carbon are probably our things that are getting changed because hydrogen and oxygen very rarely change. So chromium went from 6 down to 3. That is reduction. Carbon went from -2 up to +4, which is oxidation. So we did it correctly. We've got a reduction and an oxidation. Let's go ahead and write our half reactions. I'll start with the reduction. So we have Cr2O7 with a -2 charge. Keep that -2 on there. That's the biggest mistake I see students make, is they forget to bring that charge with them in the following reactions, and it would be wrong if you didn't have that charge because it is a polyatomic ion. And this is turning into the new chromium, which is +3. All right, the first thing is to balance the atoms. We have to meet the law of conservation of mass rule. So we've got to put a 2 here to balance the chromiums. Then we're going to look at the difference in charge times the number of atoms. So the difference between +6 and +3 is 3. We have 2 atoms, so that's going to give us 6 electrons. You're going to put them on the side with the higher charge. +6 is higher than 3. Then we need to fix our oxygens. Looks like we have 7 oxygens. So we're going to put 7 waters over here. And now we have 14 hydrogens on the right, so we're going to add 14 H+ over here. All right, and let's go ahead and do the oxidation. This time we're going to take this big old compound here and turn it into this. All right, first we're going to balance the carbons. We have 2 on the left, so we need to make 2 on the right. Now we're going to look at the difference in charge, and be careful here. It went from -2 all the way to +4. That's a difference of 6. From -2 to +4 is 6. And we have 2 carbons, so we need a total of 12 electrons. We're going to put them on the side with the higher charge. All right, carbon is good. Electrons are good. The next thing we want to balance is oxygen, because when we balance oxygen, we're going to affect hydrogen. So do oxygen first and save hydrogen for last if you have both of them. So let's be careful. We have 1 oxygen on the left, and we have a total of 4 on the right, because that coefficient of 2 and the subscript of 2. And so we need to add 3 waters on this side so that we have a total of 4 on both sides. We have 3 plus 1 on the left, and 2 times 2 is 4 on the right. So both of them are 4. All right, these hydrogens are going to be tough. Let's make sure we get them all. We have a total of 6 hydrogens in the water, plus 5, and 1 more is 6. Here's 12. So we need to add 12 H pluses on this side. All right, now we're ready to combine them, but we can't combine them until our electrons match. We have 12 in the blue reaction and 6 in the green, so the common number there is 12. We can multiply this one by 2. And again, I would go ahead and change all of your numbers so you don't forget. So this becomes 28, 12, 2 here, 4 here, and 14 here. All right, now let's see if there's anything that we can cancel. I have 14 waters on the right in the green reaction, and I have 3 of them on the left in the blue. So these 3 are going to cancel 3 of these 14. So that's going to become 11. Same thing with the hydrogens. I have 12 H pluses in the blue reaction on the right, and I have 28 on the left in the green reaction. So these 12 are going to get canceled out completely, and they're going to cancel 12 of these 28, which will leave us with 16. The electrons will always cancel out. We've got 12 on both sides. I don't see anything else that can cancel, so let's go ahead and put these together. Don't forget that charge on that polyatomic ion. All right, I don't see anything else that can cancel or be combined. And so the last thing is, if this is basic, you're going to have one more step. If this was an acidic solution, you'd be done because you can leave it with the waters and the H pluses. For basic, you cannot have H plus at the end. So what you need to do if it's basic, once you get to this step, is to find your H pluses and add the same number of hydroxides so that they become water. However many H pluses you have, add that many hydroxides so that they become water. But you also have to add that many hydroxides to the other side so that they, oops, it should be a 16, so that the law of conservation of mass holds steady. And so now we can cancel some more waters. So we're going to leave the OHs on the right side, but notice that we have 11 waters right here that can cancel 11 of these 16 to make it become 5. So our final reaction is this whole thing. I'm not going to rewrite the whole thing because it would take too long. And that's it for basic. Let's see if we have time to do one more. All right, let's go ahead and do our oxidation numbers. This chromium does not have a charge, so it's going to be a charge of 0. Over here we've got -2 for oxygen, times 4 is -8. We need it to equal -2, so chromium is going to be +6. Over here we have hydroxide, so -2 for oxygen, +1 for hydrogen. Hydroxide is -1 times 3 is -3, so in this case chromium is going to be +3. All right, let's see what changed. Probably the chromium. Yep, this one went up, that got oxidized. This one went down, so that one got reduced. And let's pull out our half reactions. Chromium is good. It's already 1 and 1. We don't need to balance that. But we do need to do the electrons. So this chromium was 0. This one was +3. So that's a difference of 3 electrons. And we're going to put it on the side with the higher charge. Then we need to fix oxygen next. Remember, when you change oxygen, you're going to change to H+. So let's do oxygen before we try to do hydrogen. We have 3 oxygens on the right, so we're going to add 3 waters over here. And the last thing are the hydrogens. We now have 6 hydrogens on the left and 3 on the right, so we need to add 3 H pluses to balance that. All right, let's move on to the reduction. Keep that charge on that polyatomic ion. And chromium is good. We have 1 and 1. The charge went from 6 down to 3. This one was +6. This one is +3. So we need 3 electrons. Put them on the side with the higher charge. Then let's be careful with oxygen. It looks like we have 4 on the left and 3 on the right, so we only need 1 water to fix that. And now we have a total of 3 hydrogens in the hydroxide right here, plus another 2 more in the water is 5. So we'll fix that with H+. All right, let's see how we're doing on electrons. We have 3 and 3, so that's good. We don't need to multiply the reactions by anything. They already cancel. See if we can combine anything else. We have 1 water over here that will cancel 1 of these 3. We have 3 H+'s here that will cancel 3 of these 5. And then we can put the 2 CrOH3s together. So let's go ahead and combine all this stuff together. So we have 2 waters here, plus chromium, 2 H+'s, and the polyatomic ion. We're going to combine those 2 CrOH3s and just say we have 2 of them instead of listing them twice. And that's all we have over there. All right, if this was acidic, we'd be finished, but this is basic. So we need to do that last step and find any place that we have H+, and we're going to add OH- to turn enough OH- to turn that into water. And so over here, we also need to add 2 OHs, OH-. And now it looks like all we can do is just combine those 2 waters, the 2 sets of water. So now we have a total of 4 H2Os over here. Chromium. We have the polyatomic ion. And that is our final answer. And we will do some more of these during class 2 if you have some more questions. I know there are a lot of steps. Good luck.